Hello friends, welcome back to MeshMind. In today's video, we will explore something very important, sensors used in IoT. From temperature to motion and even soil moisture, this sensor helps IoT devices sense the real world and respond smartly. We will understand how each sensor works, what it measures, its pin configuration and most importantly, where it's used in real life application. So let's begin. Let's start with LM35 temperature sensor. The LM35 is a very commonly used temperature sensor in electronics and IoT projects. It is a small 3-pin device that can directly measure the temperature of its surrounding and give us an output in the form of analog voltage. The special thing about the LM35 is that its output voltage increases linearly with temperature. That means for every 1 degree Celsius increases, the output voltage increases by 10 millivolt. So at 0 degree Celsius the output is 0 volts, at 25 degree Celsius it gives 250 millivolt. This makes it very easy to calculate the temperature just by reading the voltage. Now let's understand how it works. Inside the LM35 there are tiny transistors that changes its behavior based on the surrounding temperature. These small changes is then processed by the internal circuit which amplifies and convert it into a voltage. A microcontroller like Arduino or ESP8266 can read this analog voltage through its ADC analog to digital converter and then convert it into a temperature value. Taking about its pinout, when you look at the flat side of the sensor, the pins for left to right are pin 1 is VCC which is connected to a 5V power supply, pin 2 is the output pin which gives analog voltage according to the temperature, pin 3 is ground which should be connected to ground. The LM35 is used in many real-life applications like digital thermometers, cold storage monitoring, temperature controlled fans, greenhouses system, and even fire safety systems. It is very accurate and doesn't need any external calibration, which is why it's one of the best choice for beginner and professionals. Next is digital humidity and temperature sensor. The digital humidity and temperature sensor is a very popular sensor in IoT projects to measure both temperature and humidity. It is a small rectangular blue sensor that comes with 4 pins. It works using two different technologies. One is a capacitive humidity sensor and the other is the NTC thermistor to measure temperature. The capacitive humidity sensor detects the amount of moisture in the air. It does this by measuring changes in capacitance. When there is more moisture in the air, the capacitance changes and the sensor detects the changes. At the same time, the thermistor measures temperature by changing its resistance with the surrounding temperature. Both these values, humidity and temperature, are read by a small microcontroller inside the sensor. Once the values are processed, the sensor sends them out as a digital signal. It uses a special one-wire protocol to send data to a microcontroller like an Arduino or ESP8266. That means it needs only one data pin for communication, which makes it very easy to use in project. Now let's talk about the pins of digital humidity and temperature sensor. When you hold the sensor with the grid or logo facing you from left to right, the pins are: the first pin is VCC, which should be connected to a 3.3V or 5V power supply. Second pin is data pin, which sends temperature and humidity data to your microcontroller. Third pin is NC, which stand for not connected, you don't need to use it. And fourth pin is GND, which is the ground pin and should be connected to the ground on your board. The digital humidity and temperature sensor is commonly used in weather monitoring stations, smart homes, automatic climate control systems and greenhouses where you need to monitor the environment. Next is IR infrared sensor. The IR sensor is a very simple and common sensor used to detect objects or obstacles without touching them. It uses infrared light to do this. Here is how it works. The IR sensor has two main parts. One is the IR LED that sends out infrared light and the other is a photodiode that receives the reflected light. When you place an object in front of the sensor, the infrared light hits the object and comes back to the photodiode. The sensor then detects this reflection and knows something is in front of it. The sensor gives a digital output, high when no object is detected and low when object is present. Now let's look at the connection. Most IR modules have VCC connected to 3.3V or 5V, GND connected to ground and out, the signal pin connected to the microcontroller's digital input. IR sensors are used in line following robot, object counters, obstacle avoiding cars, and even in automatic doors and sanitizer dispensers. Then MQ gas sensor. The MQ gas sensor are a family of sensors like MQ2, MQ3, MQ135 and so on. These are used to detect different type of gases in the air such as LPG, methane, smoke, alcohol, carbon monoxide and even air quality. The MQ sensor work on a simple principle. Inside the sensor there is a small heating element and a special chemical material called SNO2 tin dioxide. This material changes its electrical resistance when it comes in contact with gases. So when gas is present in the air, the sensor resistance changes and this changes is converted into voltage output. It actually gives two types of output, an analog output which shows the gas level in the form of a voltage and a digital output which turns high or low based on whether the gas level crosses a set limit. The pin of a typical M2 sensor module are VCC for power, GND for ground, A0 for analog output, D0 for digital output. You can connect it to a microcontroller and easily read gas level. Many of these modules also have a small knob to set the sensitivity of the digital output. These sensors are used in gas leakage alarm, smoke detectors, air quality monitors, kitchen safety system, and smart home application. Next is LDR, light dependent resistor. The LDR is a light sensor that can detect the brightness of light in the surrounding. Its resistance changes with light. It darkness the resistance is high and it bright light the resistance become low. The sensor does not give digital output directly, so we use in the voltage divider circuit to convert its behavior into voltage that the microcontrollers can read as an analog value. There are only two pins, one connected to power through a resistor, one connected to analog input of the microcontroller and ground. It is used in automatic street lights, solar trackers, light meters, and smart agriculture systems where light detection is needed. Next is PIR motion sensor. The PIR sensor is used to detect human movement. It does not send anything out like an ultrasonic or IR sensor. Instead, it simplifies senses infrared radiation, heat coming from the human body. Every living being gives off heat in the form of infrared rays. The PIR sensor detects changes in the heat. So when someone moves near it, it notices a change in IR radiation and sends a digital signal to the microcontroller. Most PIR sensors have three pins VCC, GND, and out, which gives high when motion is detected. PIR sensors are widely used in motion activated lights, security systems, automatic doors, and energy saving home automation. Next is ultrasonic sensor. The ultrasonic sensor is used to measure the distance of an object without touching it. It works like a bat, sending sound waves and waiting for them to bounce back. The sensor sends out ultrasonic sound from its trigger pin. When this sound hits an object and returns, the sensor receives it on its echo pin. By measuring how long the sound took to return it, calculate its distance. The HC-SR04 sensor has 4 pins: VCC, trigger, echo, and ground. Ultrasonic sensors are used in robot navigation, parking sensors, water level measurements, and smart bins. Next is gyroscope MPU6050 sensor. The gyroscope sensor is used to detect the origination or angular movement of an object. It tells whether a device is tilting, rotating, or moving. In IoT, we usually use combined module like MPU6050, which includes both a gyroscope and accelerometer. This sensor works using MEMS technology, micro electromechanical system. Inside tiny parts move as the sensor tilts or rotates. These movements are converted into analog or digital signals. The MPU6050 communicates using I2C protocol and has 4 main pins: VCC, GND, SCL, clock line, SDA, data line. Gyroscopes are used in drones, mobile phones, games, controllers, gesture-based projects, and self-balancing robots. Next is soil moisture sensor. The soil moisture sensor is used to detect the water content in soil. It is widely used in smart farming. The sensor has two metal props that go into the soil. When the soil is wet, it conducts electricity better. When it is dry, the resistance increases. The sensor measures these changes and give as analog value or digital signal based on soil moisture. The module usually has VCC, ground, A0 analog output, D0 digital output. It is used in automatic irrigation systems, greenhouses, and smart garden setups to avoid overwatering or underwatering. So that was all about the most commonly used sensors in IoT, each one playing a unique role in making our device smarter and more responsive. If you found this video helpful, do like, share and subscribe to MeshMind for more valuable content on embedded systems and IoT. In the next video, we will take this further and explore actuators used in IoT, the devices that take action based on the sensor data. Don't miss it because sensor and actuator together create the full smart system. See you in the next one. Until then, keep learning and keep innovating.